Okay, so now I'm going to show you how to use the jar file which I have given you for pairwise cosine similarity to compute this pairwise cosine similarity matrix between any two nodes in the network. Okay, alright, so let us use this example. So you have to use the raw data for the weight, height, and age. So I already have created a text file that has this. So these are the node IDs. So you can have a tab or a blank space between the values, or you can have a combination of both. So here I have a tab between the node IDs and the feature vector. That is what you can call this. So you have the weight, height, and age in the raw data. Okay, so you make sure again there's no blank line, so this will be the last line, so the cursor should not go to a blank line after the last line. So that's something you have to make sure. So now go to the folder for pairwise cosine similarity and double click on the executable jar file for pairwise cosine similarity. So it will ask you to load the text file for which you want to execute. So go to wherever the folder that you have stored that text file. Okay, so it will give you the pairwise cosine similarity matrix. Now you can save this to a file for further analysis, to a text file. Okay, so make sure to you whatever the result order you want to name it and say dot text, and make sure it says all files here. So you can save it like that. I'm not going to save it here, but when you want to save it, you could do that. Now we'll see another example. So this is a pairwise cosine similarity matrix that we just got as output. Now another example, we can use centrality matrix also and generate the pairwise cosine similarity matrix for any two nodes in the network. Now I gave you the centrality matrix jar file in module 2, so you could use that and generate the centrality matrix values for all the vertices in a graph. And we'll focus here on this LCC prime DC and between a centrality. You could include any combination of centrality matrix depending on what you want to analyze. Okay, so load the run the executable and load that graph. So let me go check what graph I have it here. Okay, so you need to have an adjacency list text file like in this format where you have all the edges. Again, the convention is the lower ID first followed by the larger ID for an edge, and so with this you have entered all the edge information. Now make sure again the cursor is on the last line, not on the blank line. So this is the file you're going to load it to the centrality matrix executable. Okay, so that will get you the centrality matrix values for all the vertices. So you can press Ctrl A, highlight the, make sure the cursor is placed on the screen here. After it is placed on the screen, press Ctrl A, that will highlight all the values, and then Ctrl C to copy all the values. and you can place it in an Excel file. Now this is just LCC prime DC values of this. So these are all the node betweeners, node centrality values. Now you can see some vertices may be out of order in the way they are listed. Now you could put it back in the order if you want to, just to make sure things are straightforward. So I'm cutting and pasting this here. No, it should be done the other way. So let me cut and insert this cut cells here. So now since things are 1 0 1 2 3 4 5 6 7, now we're interested only in betweeners and LCC prime DC, so I can delete these two columns as well as delete this column. So now I can you don't need to store with the centrality name, so you can just copy this blank file, this information, and store it as the raw data. So again the cursor has gone to the blank line, so make sure it is, you can press backspace and it goes to this last line here. So these are the betweeners and these are the LCC prime DC values. I have a tab separating them, so that is okay. So you can save this. So that is what I have here to a text file, and this is a centrality program, so you can close this. Let us run again the pairwise cosine similarity jar file. Now if you see here, you get NaN for vertices 0, 6 and 7. Now the reason you get that is because the centrality matrix values for 0, 6 and 7 are all zeros. So remember, in the formula we have the denominator sum of the square root of the sum of the squares of the values. So if all the values are 0, you're going to have 0 in the denominator. So even if you have one vector to be all zeros, you'll have a problem, because then you'll have 0 times something which is also 0. So that will be 0 in the denominator, which will be NaM if you go through, if you run the program like that. So in order to get around the situation, we have to remove those entries where all the remove those vertices where all the entries in the feature vector are zeros. So you should remove 0, 6 and 7 from your text file and have only those 5 vertices with non-zero entries for the feature. Of course, one entry could be 0, that is okay, but if all the entries are 0 in that feature vector, then we'll have a problem, because the sum of the squares will still evaluate to 0 and you'll have 0 in the denominator. And make sure the cursor is still in the last line. You can resave this and you can open and analyze a file. Click here. You don't have to close the program, you can just do that again, and this is now the pairwise cosine similarity matrix. Okay, and that is what I have shown here. So I have shown here only for 5 vertices, so 0, 6 and 7 are discarded. We cannot include them for pairwise similarity scores, right? So that's a kind of weakness with this approach, as I mentioned that here. So the kind of, if you want to analyze further this network, as we will do soon in the next video, you have to remember that we have discarded some nodes. Okay. So whatever you analyze further may not be a true reflection of the entire network. You are considering only those nodes that for which they have non-zero, for which what do you call, at least one entry is a non-zero. It means you have discarded nodes that have all zeros in their feature vector. Okay.